Now, if you want to design a combinational logic circuit, we should know some rules. There is a procedure. We cannot directly perform the implementation of combinational logic circuit. We are going to understand the steps. So we are going to analyze analysis and design procedure for combinational circuits. Means procedure steps we are going to understand here. Means what is the first step, what we need to first, second what we need to do, third what we do. Total 5 steps are there for designing of the combinational logic circuit. For every combinational logic circuit design, we should follow these 5 steps in order so that we can design a correct combinational logic circuit. The design procedure starts from a verbal. The design procedure starts from a verbal or written specification. The design procedure starts from a verbal, English, right? Or written specification. Means people will tell orally, verbal, and sometimes you will get the problem through unwritten. Are you clear? Specification of a problem and transforms it into an optimized logic circuit layout. And transforms it into an optimized logic gate. An optimized logic gate circuit layout. An optimized logic gate circuit layout means you are going to design a logic circuit based on the given problem, and moreover the logic circuit must be a optimal. Optimal means efficient, means less number of gates you should use. When you want to use less number of gates, your Boolean expression must be a less. Yes or no? When your Boolean expression must be a small, when you are going to minimize of your Boolean expression. The minimization of the Boolean expression, the technique is K-map. That is why we have learned 2 hours in the last previous sessions. Got it? Right? Okay. The first step in this combinational logic circuit design, the first step is problem specification. Problem specification. Sir, what is this problem specification? Means you should analyze what is the given problem, and you should understand what contains it is, what is the behind of this problem, and what is required to solve this problem. Clearly define the functional behavior. Clearly define the functional behavior, operational rules, and constraints required for the circuit. Constraints means conditions. Constraints required for the circuit. Understand? First understand the problem, given problem, and in the understanding you analyze the problem. In the analysis you should understand what is the behavior of that functionality and what is the required operational rules and what is the required conditions we should use to develop a logic circuit. Got it? This is what first part is analysis. Like your software engineering, whenever you are going to develop a model, always the first phase must be a, what is the phase? Collect the requirements from the end user or maybe the existing application or maybe the client. After getting the requirements, the second phase is what? You should analyze the requirements. You are collected the requirements, then analyze the requirement. Yes or no? But here, the first phase already it is done. What is that? The problem statement is given by verbal or maybe the documentation by someone. Yes or no? So now you should be analyzed. Are you clear? Are you clear? Then coming to second step. Identify and assign input or output variables. Identify and assign input output variables. Means after analyzing the problem, what we need to do? You should identify how many variables are required to solve that problem. How many input variables are required to solve the problem and how many outputs are going to generate from this problem. Are you clear? And after identification, you should assign. You should assign what are the variables. In this assessing process, determine the total number of input variables n. Determine the total number of input variables n and output variables m. Determine the total input variables n as per the block diagram and output variables m needed, and assign distinct algebraic symbols and assign distinct algebraic symbols. After identification, you should assign the symbols, algebraic symbols. For example, you can consider for input capital A, B, C, like this. For input, you can use the unique symbols like capital A, B, C. For output, X, Y, Z, like that we can use. Are you clear? Are you clear? So, first analyze the problem. Based on the analysis, you can get some idea. Based on that idea, you can understand how many input variables are required, how many output variables are required, and also you can declare the variables, input variables and output variables as per the requirement analysis of your problem. So that is you should do as an engineer. Are you clear? Clear? Then third step. After preparation of the input output variable, third step is what? Construct the truth table. Construct the truth table. You know what is the truth table? There is a input variables, you know. There is a output variables, you know. So analysis already done. Whenever you are going to read two input variable data, what output it is going to come? You know, yes or no? In that way, the number of combinations of input variables you can write. That is 2 power n. Yes or no? So that number of combinations you can write. So n is a number of inputs. If your inputs are 2, then what are the combinations you can get? 2 power 2, 4. If your input is 3, if your input is 4, like that, based on the number of inputs, your truth table combinations are going to increase. The same way, the output also going to be increased. Yes or no? Is it clear? Yes, that is a truth table implementation. Got it? We have done actually this work. K maps. So it will help for this step. Third step, already we have done. So third and fourth. So write down. Create a table listing all 2 power n possible binary combinations. Listing all 2 power n possible binary combinations. 2 power n binary combination. N is what? Number of inputs. Yes or no? So that many combinations you can get. Binary combinations of the n input variable. Of the n input variable. Okay. Then how to fill? Fill in the corresponding binary value. Fill in the corresponding binary value. What is the binary value? Either 0 or 1. You can write even brackets. Fill the corresponding binary value 0 or 1 for each output variable. For each output variable under each input combination. Correct? Each output variable under each input combination. Correct? Each input combination you are going to fill under the output variable. Yes or no? If combination is changing, output is changing. Got it? Yeah. Truth table must satisfy relation. Your truth table must be satisfy relation given in the problem. Correct? Truth table must be satisfy the given relation problem. Yes or no? That is what analysis. Based on analysis only, you should design a truth table with help of the input output variable. Are you clear? You fill the truth table with help of the analysis of the problem with under the input output variable. Correct? Correct? Yeah. Coming to fourth step. Obtain simplified Boolean functions. Obtain simplified Boolean functions. Means from truth table, you are going to generate a simplified, simple Boolean function. Maybe you will get complex Boolean function. Then you should be minimize the Boolean function. Why should we minimize? If you minimize the Boolean function, then next step is the circuit construction, circuit design. Your circuit will be compact. Yes or no? Yes or no? So that is why. So you should be simplify the Boolean function from the truth table. So what is the best solution we have done? K-map is the best solution. Easy. Otherwise, if you want to use Boolean function, techniques, theorems, laws, if you want to remember, also you can do it. Are you clear? Sir, I don't want to simplify. I want to use whatever the Boolean function it is going to. Yes, you can use. You can use, no problem. But the problem is your circuit will be increased. Okay? Maybe half order, only 2 gates are enough to design. I will show you next class. design the half order. But when you are not going to simplify your Boolean expression, it will take 20 gates, maybe. So then you are wasting the money, you are wasting the time, you are wasting the space and everything, and it will take delay. The data is going to pass within 2 gates are fast, or within 20 gates are fast. 2 gates. Yes or no? It will take, maybe you are not going to be evaluate how many fraction of seconds, but still it is increasing 1000 gates. Maybe you can measure, right? Yes or no? So that is why wherever it is possible, you try to optimize your Boolean expression for designing of your circuit. Same way, whenever you are going to write your program, you try to avoid the unnecessary instruction in your program, so that your program is going to provide good quality, and speed and accuracy will be increased. Are you clear? This subject is there in the second year, the second semester, the design analysis of algorithm. How to design a algorithm and to analyze one problem we can solve multiple ways, then which is the best? Which is the best? The program which is going to take less time to execute, less memory. So that program is more effective. Yes or no? So we can write different ways. Only the recognized one, that one only, because always you try to get the more accuracy, more fast of the program. Same way, same mechanism is applicable in this logic design circuits. Clear? So what is this? Obtain simplified Boolean function. Expressions derive the Boolean expressions. Derive the Boolean expressions for each output variable from the truth table. From the truth table. To simplify these functions, into minimal sum of products. Into minimal sum of product. Sum of product means SOP. Regularly we are using. Are you clear? Or POS. What is that? Product of sum. Forms SOP or POS forms using K maps or Boolean algebraic expressions. Using K maps or Boolean algebraic expression. Are you clear? Now we are going to generate a simplified Boolean expression in the form of SOP or POS forms using K-maps. Or no sir, I want to use only Boolean algebra, means you can use Boolean algebraic laws. You can minimize your expression. Are you clear? But ultimate solution is the easiest way, the simple way is K-maps are going to use. Got it? Coming to last step, fifth step. What is the fifth step? Can you tell anyone? Circuit implementation. Right? Circuit. After understanding of this, what we can do it? We are going to implement a circuit. Clear? Sir, how to implement this circuit? How to implement this circuit? How to implement this circuit? Based on the Boolean function, then you can understand what are the gates are required to connect all the Boolean prime implicants. Yes or no? So using those gates, what are the gates? 8 gates are available. Using those gates, you can connect and you can implement a circuit diagram for the given problem. Realize the simplified Boolean expressions. Realize the simplified Boolean expressions using logic gates. Using logic gates. What are the logic gates? You can write inside of the brackets and or not, XOR, not, complement, everything. Please do it. 8 gates, NAND. Okay, all 8 gates you can write inside the bracket to produce the final circuit diagram. Using these gates, you can produce the final circuit diagram. Okay. All of you understood these 5 steps? Clear? What we need to do first? First, you need to analyze the problem and observe the problem and check the conditions, constraints are what are required, are clear, and functionality of the problem. That is analysis of the problem. Second step is what? Identify the how many number of input variables and output variables. For that, you can define that number of input variables and output variables. What is the third step? Construct the truth table based on the input output variables and fill the values, corresponding values based on the analysis of the problem. Both of you stand up on the bench. Both. And fourth problem. What is the fourth rule? Yeah, you should generate a optimal Boolean expression. Optimal Boolean expression with help of K-map or maybe the minimization of the Boolean logic in form of POS or SOP as per the requirement. Generally, we are going to use SOP, sum of product default. So otherwise, you can use POS. Once we can get the minimal Boolean algebraic expression, then you can construct the logic circuit very easy with help of the 8 logic gates you already know. Yes or no? So these are the steps we should remember while designing of the combinational logic circuits.